In this lecture, I'm going to solve this question. Suppose you have a sample of size 1 from one of the following densities. The null hypothesis is that the density is equal to 2x, where value of x is between 0 and 1, and the alternate hypothesis is that the density is equal to 2 minus 2x and the value of x is between 0 and 1. Alpha is the type 1 error and beta denote the type 2 error. We have to find the test procedure of the form reject h naught if x is less than k. So basically we have to find the value of k with alpha is equal to 0.09. And after finding the value of k, we have to also find the value of beta. Let's proceed step by step. So we are given that the null hypothesis is that the density is equal to 2x and the value of x is between 0 and 1. And the alternate hypothesis is that the density is equal to 2 minus 2x and the value of x is between 0 and 1. And we have to find the test procedure of the form reject h naught if x is less than k with alpha is equal to 0.09. We know that the probability of type 1 error is equal to alpha. So probability of type 1 error is equal to alpha. And we are given that alpha is equal to 0.09. So this means that the probability of type 1 error is equal to 0.09. Now we know that type 1 error occurs when we reject the null hypothesis when in fact it is true. So it is reject h naught when h naught is true. And this probability is equal to 0.09. We are given that we will reject the null hypothesis if x is less than k. So that means we have here x less than k, given that f of x is equal to 2x. So this is the density function because the null hypothesis is true, and we will reject the null hypothesis when x is less than k. And this probability is equal to 0.09. Now we can just solve the left hand side of the equation. So this is equal to integration of 2x from 0 to k dx, and this is equal to 0.09. I have written 0 here because x is taking values between 0 and 1. And this is equal to 2x square divided by 2. Here we have 0 and k, and this is equal to 0.09. And we can cancel this and this. So this implies that k square is equal to 0.09, and this means that k is equal to 0.3. Note that we are not considering k to be negative because x can only take values between 0 and 1. So k is equal to 0.3. So this means that the correct answer is either C or D. It cannot be A or B. Now let's find the value of beta to find the correct answer. We know that beta is equal to the probability of type 2 error. So beta is equal to the probability of type 2 error, and the type 2 error occurs when we do not reject the null hypothesis when in fact the alternate hypothesis is true. So it is the probability that we do not reject the null hypothesis when the alternate hypothesis is true. Now we know that we reject null hypothesis when x is less than 0.3. So that means we do not reject the null hypothesis when x is greater than or equal to 0.3. So this means beta is equal to probability that x is greater than or equal to 0.3, because this 0.3 is the value of k, given that the density is equal to 2 minus 2x because the alternate hypothesis is true. And note that the value of x can be between 0 and 1. So this means that to find the value of beta, we have to integrate 2 minus 2x from 0.3 to 1. And we have dx here. So this is what we have to find. Now beta is equal to 2x minus 2x squared divided by 2, and 0.3 here and 1 here. And this implies that beta is equal to 2 minus 1 minus, actually we can cancel this. So it is minus 0.6 minus 0.09. So this is equal to 1 minus 0.51. So this implies that beta is equal to 0.49. And this means that the correct answer is part D. So this is your answer in this case, and that's it for this question.